This video is going to cover a quick review on transformations. Here's our first question. What would be the coordinates of the vertices of the triangle below if you reflect it across the y-axis and then translate it 8 units down? Alright, so first let's reflect the triangle over the y-axis. Now, you could do it visually, but I'm going to go over how to do it with the coordinates as well. So first, let's write down the rule for reflecting it over the y-axis. To reflect a shape over the y-axis, you have to change its x-coordinate to the opposite sign. So whatever x is, you're going to change it to the opposite sign. So our coordinates for point A is 1, 5. So if we reflect it over the y-axis, it's going to become -1, 5. And I'm going to put that point on the I'm going to plot that point on my coordinate plane. For point B, the coordinates are -4, 6. So B prime is going to become +4, 6, and I'm going to plot that on the coordinate plane. And point C is located at -3, 3. So it's going to become C prime is going to be at 3, 3. And let me plot that point. So there in red, I have my triangle after reflecting it over the y-axis. But now we have to do the second transformation, which is a translation 8 units down. So what we're going to do is take those coordinates that are in red. Those are going to be our new starting point. And we're going to use those coordinates to move the triangle 8 units down. Okay, so you need to remember that to move 8 units down, the way you do that is you're going to subtract 8 from the y-coordinate, because the y-coordinate controls the movement up and down, and the x-coordinate controls the horizontal left and right movement. So since we want to move the triangle 8 units down, the easiest way to do that is to subtract 8 from whatever the y-coordinate is. So let's take A prime, which is the coordinates are -1, 5. So we're going to subtract 5 minus 8. And that's going to give us A double prime, which is going to be at -1, -3. And let me plot that on the coordinate plane in green. B prime is at 4, 6. So I'm going to subtract 8 from the y-coordinate, and that's going to give me B double prime at 4, -2. And I'll plot that in green. And my last coordinate is going to become from 3, 3. When I subtract 8, it's going to become 3, -5, and I plot that point, and there's my triangle after the second transformation, and that gives me my answer. Oops, sorry about that. That gives me my answer. The coordinates are A double prime. Well, you can see them on the screen, the coordinates. You could have also done it visually as well, but just keep in mind, if they don't give you a picture, you're going to have to know how to do it with the coordinates unless you draw your own picture. You should be familiar with how to do it both ways. And for the reflection, realize that, for example, if A is 1 unit away from the y-axis, then A prime has to be on the other side 1 unit away. If B is 4 units away from the y-axis, then B prime has to be on the other side of the y-axis 4 units away. All right, so you could have done it that way as well. Okay, next question. Square ABCD is shown with vertices at the following coordinates. ABCD is dilated about the origin so that x, y will become 3.5 times x and 3.5 times y to create A prime, B prime, C prime, D prime. What is the ratio of AB to A prime, B prime? Okay, so basically, it may have sounded complicated, but basically they want you to do a dilation by a factor of 3.5 to the square. And they want to know what's going to be the ratio of side AB to side A prime, B prime. You can answer this very quickly without doing any work, but let me first explain it so that to make sure everyone understands, all right? So let's first dilate it. So I'm going to write the rule, the algebraic rule, and let's get all of the coordinates and multiply the x and the y coordinates by 3.5. So that's what I'm doing with point A. The coordinates are -2, 2. I'm multiplying each coordinate by 3.5, and that's giving me A prime, which is at -7, 7. I'm going to do that with B, C, and D. And you can see the new coordinates are or the coordinates of the image on the screen. Okay, now let me plot those points. So in red there, you could see my dilated square. Okay, now if I were to measure the length of side AB, all right, side AB is 4 units long, and side A prime B prime is 14 units long. Okay, so the ratio of AB to A prime B prime is 4 to 14. But usually when they ask you what the ratio is, they want you to simplify that. They want you to simplify it so that usually they want the answer to say 1 to what? Okay? So how do I turn that 4 into a 1? Well, let's divide both of those numbers by 4. All right? So when I divide both of those numbers by 4, I get a ratio of 1 to 3.5, which is my answer. Okay? My answer is a ratio of 1 to 3.5. By the way, notice that how I wrote my answer, because you need to be familiar that when you see it written that way, that means 1 to 3.5. And also realize that I could have skipped that entire explanation and everything I just showed on the screen by just looking at the rule. Okay, I could have just looked at the rule and written, if that's all they're doing to the pre-image, a dilation of a factor of 3.5 to the x and the y coordinates, then I could just get my answer from there. The ratio is going to be 1 to 3.5. So make sure you realize that in case you see that on your final exam. Okay, next question. List all the angles of rotation less than 360 degrees for the regular octagon below. Regular means that all the sides are the same length and all the angles are the same measure. All right, so we have an octagon. An octagon means that it has 8 sides. And the way that you do this is very simple. You always do, well, first of all, the angle of rotation for a regular polygon can be found by dividing 360 degrees by the number of sides. Okay, so our octagon has 8 sides, so we're going to do 360 degrees divided by 8. That gives us 45 degrees. That means each time you rotate this polygon or this octagon 45 degrees in either direction, it'll look exactly the same way. It'll match up and look exactly the same way it looks now. Okay, but they want us to list all the angles of rotation, not just the smallest one, but all of them that are less than 360. So you have to do 45 times 1, 45 times 2, 45 times 3, etc. You got to keep listing them all until you get all of them that are less than 360. So our answer is going to be 45, 90, 135, 180, 225, 270, and 315. One way you could do that is just keep adding 45 in your calculator until you get all of them that are less than 360. Okay, next question. Write an expression that represents all the possible degrees of rotation that map the regular octagon onto itself. So I'm using the same picture, the same shape, the same octagon from the previous question. All right, so they want us to write an expression, not an equation, all right, but an expression. That means our answer does not have an equal sign. We have to write an expression that represents all the possible degrees of rotation that map the regular octagon onto itself, okay? So we just did this in a previous question where we saw that the angle of rotation is 45 degrees. And we found that by doing 360 divided by 8. Okay, so this is very simple. 360 divided by 8 gave us 45 degrees. So our answer is just going to be 45n. The n represents the number of rotations. So like if you rotate it one time, 45 times 1 is 45. If you rotate it 2 times, 45 times 2 is 90 degrees. If you rotate it 3 times, 45 times 3 is 135, etc. So that represents all the possible angle of rotations. The n represents the number of times that you rotate the shape. So that's very simple. Make sure you're familiar with that because that's an easy question to get correct on your final exam. Next question. Write an expression that represents all the possible degrees of rotation where both regular polygons shown below are mapped onto themselves. All right, so let me make sure you understand what this means. We got to write an expression that tells you the all the possible degrees of rotation that I could do to both shapes to get them to look exactly the same way that they do now. Okay, so let me tell you how you do this because this is also not difficult. First thing we're going to do is, first of all, on the left we have a hexagon. A hexagon has 6 sides. And on the right we have an octagon which has 8 sides. The first thing I'm going to do is Find the angle of rotation for the hexagon. And we do that just like we did in the previous two questions. We're going to divide 360 degrees by the number of sides. So the hexagon has 6 sides. So let's do 360 divided by 6. That tells us that the angle of rotation is 60 degrees. That means every time I rotate it 60 degrees in either direction, it'll match up to the way it looks right now. Okay, next, let's list all the angles of rotation less than 360 degrees. All right, so that means 60 times 1 times 2 times 3. When I list them all, there's my answer. Okay, now let's do the same thing for the octagon. We've already done it in the previous two questions, so you should know by now. You just divide 360 by 8, and that tells us that the angle of rotation is 45 degrees, and the list of all the angles of rotation less than 360 are those. Okay, now just find the smallest angle of rotation that they both have in common, which in this case is 180 degrees. That means each time I rotate either shape 180 degrees, they'll match up with the way they look now. So since they want us to write an expression that represents that, my answer would be 180n. All right, 180n. Let's try another question exactly like this, but with two other shapes, okay? So here's our next question. Same thing. Write an expression that represents all the possible degrees of rotation where both regular polygons shown below are mapped onto themselves. So here we have that same hexagon along with a triangle. So the hexagon we already did. That information is still the same, that the angle of rotation is 60 degrees. And those are all the angles of rotation less than 360. Now a triangle, it has 3 sides. So we're going to do 360 divided by 3. And that tells us that each time I rotate it 120 degrees, it'll look exactly the way it looks now. Okay, so let's list all the angles of rotation for the triangle that are less than 360. And we have 120 and 240. Now just pick the smallest one that they have in common, which is 120. And I'll use that to write my expression. Every time I rotate both shapes 120 degrees, it'll match up to the way that it looks now. Okay, and again, remember, an expression is not the same thing as an equation. An equation involves the equal sign. An expression does not. Okay, for our next question, select all the transformations that carry the rectangle onto itself. Okay, in other words, select all the transformations that when you do them, the rectangle will look exactly the same way that it looks now. The vertices will be in the exact same spot. Okay, so our first one says a reflection across the line JK. All right, so locate the 2 points JK and imagine drawing a line. Remember that a line goes into infinity in both directions. So if I draw a line through the 2 points JK, I have that line. If I reflect the rectangle over that line, it'll carry the rectangle onto itself. It'll look exactly the same. So therefore that answer is correct. Okay, our next answer choice says a reflection across the line JM. So locate those 2 points and let's draw a line through JM. Okay, so if I reflect the rectangle across that line, it should be obvious that it's going to carry onto itself as well. So that answer is also correct. Okay, answer choice 3, a reflection across the line BC. Okay, so look at side BC. If I reflect the rectangle, well, if I draw a line through points BC, I have that line. If I reflect the rectangle over that line, will it land on top of that same rectangle? Of course not. It's going to be on the other side. So no, it does not match up. So that answer is wrong. Okay, answer choice 4, a reflection across the line AC. This one is one that's easy to be confused by. Okay, so the line AC is that. If I reflect the rectangle across from that, you're going to get a shape that looks approximately something like that. Okay, so obviously that does not match up. Make sure you realize that because that's one that you could easily be confused by on an exam. All right, so no, that will not match up. A reflection across that diagonal line, AC. Okay, so that's wrong. Okay, 5th answer choice, a 180-degree rotation about point K. All right, so look at where point K is. Imagine rotating it 90 degrees and then 90 degrees again. for a 180-degree rotation. And for a 180-degree rotation, it does not matter which direction you rotate it. You could rotate it clockwise or counterclockwise. It's still going to end up in the same spot. So let's look at what that looks like if you rotate it clockwise. That's to the right, 180 degrees. It's going to look like this, more or less. Okay, it's going to end up there. So as you can see, it does not match up. So that answer is wrong. Okay, let's go to our last answer choice. A 180-degree rotation about point J. By the way, when it says about point J, that means the center that you're rotating it around is point J. Point J is exactly in the center of our rectangle. So if we rotate it 180 degrees about point J, it's going to do that. And again, it doesn't matter for 180 degrees. It doesn't matter if you rotate it counterclockwise or clockwise, to the left or to the right. For 180, it ends up in the same spot. And as you can see, that matches up, so that answer is correct. Okay, for our next question, triangle XYZ is transformed to create triangle X prime, Y prime, Z prime. Line segment X prime, Z prime is a dilation of line segment XZ about the point 4, 0. What is the scale factor of the dilation? Okay, for this question, first of all, I have the center of dilation in red. It's point 4, 0. That's not a big deal though for this question. With this question, we could like dive in deep and really analyze it so that you could understand everything, but we don't really have time for that. So to keep the review quick and to the point, I'm first going to just show you quickly the correct way to do it, and then I'm going to give you a shortcut that's going to be a lot easier. All right, so first of all, let's see the correct way to do it, and I'm going to go through it quickly. You could always pause the video. All right, so first thing I'm going to do is find the length of segment XZ by getting the rise and the run and using the distance formula. And so the length of line segment XZ is the square root of 72, which when I simplify it further would be 6 square root of 2. And then I'm going to do the same thing for the other line segment X prime, Z prime. When I get the rise and the run, it's 2 and 2. So I'm going to square them, add them together, and get the square root. And that's going to give me square root of 8 or 2 square root of 2. If that seems too complicated for you, don't worry. I'm going to give you a shortcut in a second. But you could always pause the video and look carefully at what I'm doing to see how I'm getting the length of those line segments. Okay, now, to get the scale factor, you always put the new side on the top and the old side on the bottom. The correct terms that to use are the image on the top and the pre-image on the bottom. However, with students, I prefer to just say new and old. I think it's more to the point. You could remember that because it's in alphabetical order. The N on the top, the O on the bottom, and it spells no. Okay? So the new side is square root of 8. The old side is square root of 72. And when I simplify that, I get 1/3. Or you could have done it this way. The new side is 2 square root of 2. The old side is 6 square root of 2. And when you simplify that, you're also going to get 1/3. Again, you could pause the video and look at that slowly and analyze what I did. But let me get to the shortcut, which is what's gonna be most useful for most students. Okay, so for the shortcut, let's look at the two. As you can see in each triangle, there's two sides that are slanted, and each triangle has one side that is horizontal, and those are easy to count. Okay, so let's count the length of each of the horizontal sides. So side YZ and side Y prime Z prime. Okay, so side YZ is 3 and side Y prime Z prime is 1. Okay, so let's put that into our formula for the scale factor. The new side goes on the top, the old side goes on the bottom. So that's going to give you 1/3. And you always got to check if that could be simplified. In this case, that fraction is already simplified, and that's our answer. All right, the scale factor is 1/3. Okay, one thing I want to make sure you realize is that notice that we're starting with a big triangle. Okay, the pre-image, our original shape is the big triangle, and we're dilating it and making it smaller. So because we're making it smaller, you have to realize that the scale factor has to be a number that's between 0 and 1. That's why the scale factor is 1/3. I'm pointing that out because it's easy to get confused and think that the scale factor is 3. It would be 3 if we were starting with a small triangle and making it bigger into the big triangle, but we're not going that way. We're going the opposite way. We're going from the big one to the little one. So that's why the scale factor is 1/3. Okay, it has to be less than 1. All right, now let's go to the last question in the review. Rectangle ABCD is transformed to create rectangle A prime, B prime, C prime, D prime. Write an algebraic rule to describe the transformation of rectangle ABCD to rectangle A prime, B prime, C prime, D prime. Okay, so we got to write the rule that tells us what's happening with these coordinates. And the way that we're going to do that is just by comparing the two coordinates. If you compare the two coordinates, it's actually really simple. So let's start. And by the way, that's what the rule is going to look like. First, you always write parentheses x comma y, then you put the arrow, and then you're going to put parentheses and what's happening to the x and to the y. So let's start by writing out the coordinates of A, B, C, and D. All right, so A, B, C, and D. They are the coordinates of our pre-image. Okay, next, let's write the coordinates of our image, A prime, B prime, C prime, D prime. Okay, so there are our new coordinates. Okay, now let's analyze what's happening with the x coordinates and what's happening with the y coordinates. So let's start with the x coordinates. Here are all our x coordinates and in our pre-image, and let's compare it to the x coordinates in the image. So if you look at that, you can see that the numbers are staying the same, but they're changing to the opposite sign. It's going from 1 to -1, 4 to -4, 4 to -4, and 1 to -1. Whenever the coordinates are changing to the opposite sign, the way you put that in the rule is by putting a negative sign. So we're going to put a negative sign in front of x. The negative sign means it changes to the opposite sign. That's the effect that it has whenever you put a negative sign in front of a number. It changes it to the opposite sign. Okay, now let's do the same thing with the y coordinates. So let's analyze the y coordinates in our pre-image and let's compare them to the y coordinates in our image. So if you know your multiplication tables and you compare those, the relationship between those two numbers, it's going to be obvious to you that the pre-image, all the y coordinates are being multiplied by 3 to get the y coordinates of the image. 3 times 3 is 9, 3 times 3 is 9, 1 times 3 is 3, and 1 times 3 is 3. So the way that we're going to write that in our rule is 3 times y. Okay, and that's it. That's our answer. Our algebraic rule is x comma y, and then we write the arrow, becomes -x comma 3y. And that's our answer. Okay, that's it for this review on transformation.